In this video, we're going to discuss the money multiplier, which is how banking systems end up actually creating money. So let's start by thinking of a new country, the Republic of Blanton, which begins with no banking system at all, and then the government issues 1 million bones. And banks are then created, and they're going to store cash. So if you've got a bunch of bones you've collected, you don't want to bury them in your backyard, you want to save them in the bank, you can put them in the bank, and then payments are made by withdrawing cash or by writing checks, which work just the same way they work here. You can write a check, and somebody else will take it, and money will be transferred from your account to their account. So without interest, banks can earn profit from depositors' fees. So they're not going to earn interest on the money you deposit. So let's assume there was 1 million bones in currency, and they're all deposited in the bank. So now we have 1 million bones in assets and 1 million bones in liabilities. So bank reserves are cash or similar assets that are held by banks, and these are used to meet depositors' withdrawals and payments. So at this time, Blanton's banks have 100% reserves, right? Everything that's an asset is also in liabilities. Okay? All of the currency that's been deposited is held in deposits. 100% reserve bankings when the bank reserves equal 100% of their deposits. Cash in a bank's vault is not part of the money supply. So some banks do have vaults. These large vaults can hold cash. Usually they hold other assets like art or gold, but this is all unavailable for payments, and bank deposits that are available in transactions are part of the money supply. So if you take a $100 bill and you put it in your checking account, that is the money supply because you can still access that $100 today. But if you put something in a bank vault, it's not necessarily accessible today. Bankers realize in the Republic of Blanton that the inflows and outflows from vaults leave some bones unused. So only 10% of deposits are needed for transactions, and the other 90% are just sitting in the vault doing nothing. So they decide, hey, we can lend this to borrowers for a fee, and they'll pay us interest. So if they make loans, they can put more money into the economy and increase the money supply. So let's see how this works. So currently we have 1 million bones deposited in the bank, and we're going to take all but 10% of those and loan them out, right? So now we've created 90,000 bones worth of loans, and we only have 100,000 bones worth of currency currently sitting in the bank. Okay, so this means that the reserve deposit ratio is 0.1, right? Because deposits is 1 million, and our reserves are 100,000. This is called a fractional reserve banking system. That just means that the amount of currency or reserves is less than the amount of deposits. So let's assume we made those loans of 900,000 bones, and they're sent to dog farmers, and the dog farmers spend the 900,000 bones, which are later deposited back into the banks, right? So they spent the 900,000 bones, they bought a few harvesters and some tractors. Now they're driving around farming up, and the people who sold them, the harvesters and tractors, deposit their bones back into the bank. So now the bank is back whole. We have 1 million bones in currency, and our deposits are 1.9 million bones, okay? Because we've loaned out this 900,000. So the bank can continue doing this. So at this point, they're going to do the same thing. We have a difference here of 900,000, right? So we can loan out 90% of this 900,000. And we'll loan out 810,000 bones, and then those again are going to be redeposited, right? So we loan out 810,000, which makes our loans back up to 1.7 million, and our deposits up to 2.7. The loans are spent and redeposited, and this can go on until we reach an equilibrium. And at the equilibrium, we're going to have 1 million bones in currency, but we will have 9 million bones in loans, which means our banking deposits are actually 10 billion. So we started with 1 million bones in currency, and the bank reserve deposit ratio of 0.1 led us to deposits of 10 million bones and having 10 million bones in the money supply. So if we have 10% reserves, each bone in circulation is going to support 10 bones in deposits. So deposits in the banking system satisfy this relationship where we have a reserve deposit ratio. Bank reserves divided by bank deposits is going to equal our reserve deposit ratio. we want to solve just for deposits, we can just multiply by deposits on both sides and then divide by reserve deposit ratio. We get bank deposits equal bank reserves over the reserve deposit ratio. So let's try another example here. Blanton residents hold 500,000 bones as currency, and they deposit 500,000 bones into the bank. Okay, so banking reserves are now 500,000 bones. The reserve deposit ratio is 10%. What is the value of bank deposits? Well, there's banking reserves of 500,000 and a reserve deposit ratio of 0.1. So bank reserves 500,000, reserve deposit ratio is 0.1. 500,000 divided by 1/10 is 5 million. Okay. Now we know that bank deposits is 5 million. What is the value of the money supply? Well, the money supply is the currency held by the public plus bank deposits. The public holds $500,000 in currency, and we have $5 million in bank deposits. So the money supply is 5.5 million. An interesting thing happens around Christmas time, right? So let's suppose again that banks hold $500 billion in reserves and the public holds $500 billion in cash. We have a reserve deposit ratio of 0.2. This means that the money supply is going to be the currency held by the public, 500 billion, plus the currency in banking reserves, 500 billion, divided by the reserve deposit ratio, so 0.2, right? So 500 times 5 gives you 2,500, and 2,500 plus 500 is 3,000. So 3,000 billion is 3 trillion. So our money supply is $3 trillion. And then as Christmas approaches, consumers are going to reduce bank deposits by 100 billion. People like to spend money around Christmas time. So they're going to have to pull their money out of the bank and spend it. So banks now only have 400 billion in reserves, and the public's going to hold 600 billion in cash. So what we've done here is we've taken 100 from here and put it in there. So now we have 600 cash and 400 in bank reserves, and our reserve deposit ratio is still 0.2. So now we have 600 plus 400 times 5, which is 2,000. Now 2,600 is our money supply. So we've lost $400 billion in money supply because people wanted to spend money around Christmas. So if we reduce bank deposits, we're going to reduce the money supply. Also, if we increase the reserve deposit ratio, if we increase the denominator over here, we're going to decrease the money supply. So a change in the reserve deposit ratio is going to affect the money supply, and a change in where the currency is being held, either in person or in bank reserves, will change the money supply.